If you're asked to solve a particular question, you don't use that first principle always to do that. Although we're going to use first principle to solve at least one question, and then at most 2 questions if need be. The rest of the problems you meet when you're dealing with differentiation, you use the standard. And the standard are just a couple of formulas that you need to memorize, and they are very simple. Just this one changed to this, the other one changed to that, that's it. So a few of them that you should give attention to at this level. We have functions, and then we have their dy, dx. The first is functions that we refer to as polynomial rule related function. They come as polynomial function actually, but the thing is that the power can be any type of number. So I have this y equal to f of x raised to the power of n. Somebody gives you y equal to f of x raised to the power n. For example, I give you y to be equal to, let us say, 2x raised to the power 5. This function is of this type. You can see a function of the independent variable. You see y depend on x here, so x is independent, y is dependent. So you notice that it follows this format. Your n, look at it, this power. This is our f of x, our function of x. Now look at this. If I give you y to be equal to x plus 3, let's say x raised to power 5 plus 3, all raised to power, let's just say minus 2 over 3. This function is also defined by this. How do we even interpret this function? It's very simple. You are given the dependent variable, whatever alphabet that they want to use, equal to, you now have a variable function as base. You have a variable function as base, just like you have this. Then raised to the power of a number. Raised to the power of a number. Take note, you have a base as a variable. The base will be a variable. Variable in the sense that you are seeing, an alphabet in the base here. Then the power will be a number, because this n here is a number. Now to get your dy dx, this is the formula. Anytime you are given a function like this, your dy dx is equal to, use the power to multiply the base. What is the power here, Kamdeli?
N.
Correct. So we're going to write n times, what is the base here?
F of x.
Correct, f of x. Then go to the original power and subtract 1. So this is going to be n minus 1. I hope it is still showing. Let me check. Good. Now, this is the first step, which is very simple. Is this process difficult, Kamdeli? Is it difficult? Use power, multiply base, go to power and subtract 1. Do you know that somebody in grade 4 can actually do this? Do you think it's possible?
Yes.
Good. Then,
Yes.
at this point, you're not done yet. You now multiply again by, go ahead and differentiate this function of x. Because when an examiner gives you a question, this function of x will be a particular function. Like in this case, now that function of x is simply x here. Here, that function of x, which is the base, is x raised to the power 5 plus 3. I didn't mention 2 here because this 2 is a pure number multiplying, so it's not taken as a function of x. It's not. Whenever I have a pure number multiplying, you don't respect that pure number as a function of x. You don't. In this case, this 3 is part of the function of x because it is added. Under addition and subtraction, that pure number will be combined as part of that f of x. Here, our f of x is the base, which is x raised to the power 5 plus 3. So you are expected to differentiate that f of x. But at this point in time, we don't know what that f of x is. It can be any type of function, like I said. When we start picking questions, you will see it. But just remember that you need to differentiate with respect to x, whatever that original f of x is. You have to differentiate it with respect to x. You have to differentiate it with respect to x. So take a look at it. Take a look at it. You can copy it out, please. So that is a formula. That is a formula. One formula obtained for differentiation. This function, sometimes we can call it polynomial function. Although it is not actually polynomial only. But the whole idea of polynomial is that you have a base which is a variable, and then you have numbers as power. That's really what we refer to as polynomial. The only thing is that in polynomial, the powers are only positive whole numbers. The powers are only positive whole numbers. But if you come to differentiation, although this function is polynomial alike, it's polynomial related. The only difference why sometimes we are kind of worried calling it polynomial is that this power can be any type of number. It can be positive, it can be negative, it can be a whole number, it can be a fraction. But polynomial specifically, this number cannot be any type of number anyhow. It is just a whole number, positive always. But please permit me candidly, we are going to be calling this type of function polynomial function. Are you getting me right?
Yes, sir.
Now, I've told you the difference between having a pure polynomial and having just a term that has a power where the power is a number. But just let's take it as polynomial function. So anytime I'm referring to it, you would remember, oh, that function, okay, this is how I was taught that we do it. Use the power, multiply the base, go to the power and subtract 1. Then when you are done with that, remember to differentiate the f of x. Now, I want you to understand something. I want to give you one secret, a powerful secret now. So please, pay serious attention. Are you ready to hear this powerful secret?
Yes, sir.
With this powerful secret, the truth is that in your objective case, you can solve a question in fact, you can solve a question without writing anything down.